Welcome to our first lesson of pre-calculus for yes. We start with Unit 1, polynomials, polynomial functions, and equations. This is your notes booklet. So you come back to this booklet when you need to study something. If you need to ask questions, this is the booklet. And your practice booklet is where you keep coming back to and ask questions from. I like to write my name on these booklets. I write the section too, because I have tons of these ones. I want to know which section I did, but for you, just write your name in case you forget it behind. We'll know who that belongs to. Here are some old or from past classes concepts that even though you should be knowing these ones, so we will go over through them quite into some detail. And then the new ones that pertain to grade 12 would be the ones at the bottom. So lesson 1, we will focus on polynomial definitions and polynomial operations. The goal is to reach the very end of this class where we will be doing synthetic and long division. That's the new concept that belongs to grade 12 pre-calculus. Everything up to that is review. Okay, so it's from grade 10 and grade 11 pre-calculus, grade 9 a little bit. Okay, so let's get started. Polynomial definitions. Polynomials are common algebraic expressions. You see them throughout pre-calculus and calculus. We will be focusing on single variable polynomials. That means they're only going to have one variable, x, in them. And they will be of these forms: powers, like x is the base of that power, and n is going to be a number. And then in front of this power, you also can have coefficients. So we have these groups of powers that are added and subtracted, and we will create what we call a polynomial expression. So let me do that. Now, if power word is the first time you hear it, or today, or you haven't heard it in a long time, let me break it down for you and see what the parts are. So a power is an exponent form, okay? So it would have a base. And that's where you're going to see your variable, the x variables in the base. And then it will have what we call an exponent. The number in the superscript is called the exponent. Now the whole thing is called the power. And this x at the end, what does that mean? It means x times x times x times x times, how many times x by itself? N times. So instead of writing that for x at the end, right, we just simplify it in one single form, x to the n. Right? Just so you know, it's not times, right? It's not x times n, it's x times x times x times x. If we have x to the 3 like that, that just means x times x times x, right? By itself 3 times. And this number in front, the a, is going to be another number. It's called coefficient. So now, formally, we can define a polynomial expression in general or generic form as one chunk plus another chunk plus another chunk, all the way until you reach what we call the free term. The last term can be a term with no x in it. So plus 7, minus 5, you know, so it won't have anything with x in it. But all it does here it describes a situation like here, right? A power, it may have a coefficient, okay? It will have an exponent, okay? And they're just added and subtracted. It's just a fancy way of writing these polynomial expressions. Now, here's an example to kind of visualize it a little bit better. So here's the first power group. You have a coefficient of -5, and your power is x to the 4. And there's a second group, the 1/2 times x to the 3. And there's another group with a coefficient of -0.25 times x to the 2, minus 1 times x to the 1, and then the free term, the last term, plus 7. So every time you have an expression, a polynomial kind, where you're starting with the highest exponent of these powers, and you go in decreasing order to the lowest exponent or no power, that's what we call general form. Sometimes they're scrambled, they're not in this order. They're still polynomial expressions, but they're not in general form, okay, in the fancy form that they should be in. These powers, the groups that I keep calling them chunks, they're called terms. So anything that adds or subtracts in math, they're called terms. These power chunks, they're terms. Things that multiply in math, they're called factors. It's important to know some vocabulary. Okay, so now the exponents of each of these terms, the n's, the n-1, all it means here, n-1, is that this one is the highest, and then the next one is one lower, and so forth, okay? These are natural numbers. And they are written in descending order or decreasing order. If they are, again, in general form. What does a natural number mean? That's the notation for natural number sets. Do you know what natural numbers are? That's right. Counting numbers, 1, 2, 3, 4, and it keeps going all the way to infinity. Counting. It can be actually a whole number too. Depending which country you're in, you may say that the set that contains 0 is natural numbers with 0. But in North America, we say whole numbers for that, okay? So yes, the free term, the 7, is actually x to the 0, because anything to the 0 except 0 is 1. So that still will cancel out. That still will count for it. So in that case, this would be whole numbers. Just a technicality. Now, for these polynomials, we have names that come from the highest exponent of these terms, these powers. They're called the degrees of the polynomials. So the degree, just like the degree of an angle, the same name, the same word, the degree of a polynomial is given from its highest exponent. Now, a side note, in grade 10, or I think maybe grade 9, when you first discussed polynomials, you did look at polynomials with multiple variables. So if you would have something like x squared y, the degree of this polynomial will be the sum of their exponents, so it'll be 3, okay? So for us, because we only have one variable type, just x is the highest of those powers, okay? So that's fine. The coefficients, the numbers that sit in front of our powers, like -5, +1/2, 0, and -0.25, these ones can be any number you can imagine. These numbers are called real numbers. So -5 is a real number, 1/2 is a real number, square root of 3 is a real number. So they're all part of the set. All of the numbers that fill the number line, it's a real number. Now, some of these coefficients are special, okay? So we're going to define them in a special way, and we're going to remember they were special because they will carry some information or some tools for us to graph polynomial functions when we get to them. Now, the first one is the leading coefficient. The leading coefficient is not the first one you see. It's the coefficient that goes along with the highest polynomial term, okay? The highest degree of polynomial terms. So it's gonna be -5 for this example, because that goes along with the highest power there, the x to the 4. Okay, that's the leading coefficient. And it cannot be 0. Because then you wouldn't have that first term to begin with, because you're timesing by 0, right? That's the only condition there. It cannot be 0. And then the last one, the constant term, the coefficient that doesn't have an x term, sometimes we call it the free term. The free term is the number by itself. Sometimes if you have a polynomial expression that doesn't have anything, for example, if you have 3x squared minus 7x, okay, what's the free term for this one? What can I add here as a number that doesn't change the given expression? What number? No, because if you add 1, you add 1, right? 0, that's right. If I add 0, I haven't really changed anything, right? So if you're asked what's the free term of this expression, the free term would be 0, right? The number 0. Because you can add it, you can leave it out, it doesn't matter. It's still the same polynomial expression. Any questions for the first page? Now you'll be writing a lot, especially the first month. You're gonna feel it when we write so much on every day. But if you fall behind, definitely during breaks, you can tell me to go back. You can copy the notes. I also provide you with a binder at the back of the room. Do you see that big binder there? That has notes for the entire course. So if you like to take pictures ahead of time, you can take pictures of the notes that are coming. They might not look exactly the same because I'm not a robot. I can't do exactly the same things every time, but they are the same notes, might be differently approached, but not a copy of one another. Okay. Naming polynomials. We're gonna name them by their highest exponents first, and then we're gonna have a list here of common names, what we know them by. So the first one, highest exponent for 3x is 3x to the 1 there. Even though 1 is not written, that's why it's not written. It's implied for exponents. So that's going to be degree 1. That's the name of this polynomial, degree 1 polynomial. And the common name for that is linear. A linear polynomial, okay? Now the next one, if you look at all of your chunks, all of your terms, the highest exponent you see is 2. That's going to be a degree 2 polynomial. And another name for it, the common name is quadratic. The next example here, we have, you look at the entire polynomial, you see the highest exponent is 3. That's going to be what? Degree 3 polynomial. And the common name, anybody knows it? Cubic. The next one is degree 4, because that's the highest exponent, 4. You can see the pattern, right? The same thing over and over. The name for the degree 4, it's called quartic. Quartic. And degree 5, and that's how high we will go, up to 5. And that's called quintic. You can see the Latin in these names, right? Quinceanera, right? Quintic. A lot of the Latin languages might have an easier time with these words. And then we can also refer to some polynomials if we want to focus on how many chunks, how many powers make up the polynomials by the number of these chunks, by the number of terms it contains. So if a polynomial has one term in it, like this one, this is the degree 2 polynomial, but it has one power only in it. Notice it doesn't have anything extra. That's called a monomial. So the prefix mono means one. So one term. And then if we have two terms, like this linear polynomial that has two terms, we call it binomial. A very common binomial is the difference of squares binomial, because you have a factoring method for that, factoring rule for that. But we will get to those ones a little bit later. Three terms, it will be trinomial. Anything more than three polynomials. Okay, you don't have a name for it. You can be specifying how many terms. If you want the reader to know how many terms it has, you can say polynomial. This polynomial has 6 terms, you know, you can say that as well, but polynomial is the name for it. They're all polynomials, but monomial, binomial, and trinomial gives information about how many terms they have. Okay, so we would rather use that than polynomial, because that's the term that encompasses them all. Any questions for naming polynomials? So this is the pages that I usually take a break, but because it's only been 2 pages, we're going to skip this and then stop at the next one, okay? But I photocopy your notes keys at the very end of your notes package. So if you flip all the way to the end, see if you can find where it says your turn solutions. All the way after the 3rd lesson. At the very, very end, I photocopy the whole booklet. So when you do these questions, you have the entire solution there. So it's up to you if you're going to tackle these or some of these during break times or after class. So we have time or at home, right? But you have these extra questions to go through. And they're usually right after the notes we just done. So they are connected, okay? Sort of types of practice questions, okay? These ones are just testing you on understanding the definitions and the naming of polynomials. You want to get straight into operations with polynomials. The first one, first kind, adding, subtracting, because they're very similar to one another. So the idea of adding, subtracting polynomials are done around or through the idea of like terms. So we can add or subtract 2 or more polynomials if they are alike. When are they alike? When the powers are exactly the same. So then when you have 2 polynomials that are exactly the same powers but different coefficients, all you have to do is merge or put together those coefficients. So if I want to add these two, 5 plus minus 3, I will get 2x squared, right? So I call these apples. So 5 apples minus 3 apples. How many apples you have left? Because if it's the same type, you're allowed to put them together. So 2 terms are alike if they have the same base and exponent the same. So the x is the same, the base is x for both of them, and also their exponents. The power has to be the same. Notice these examples for what's not alike. If I have 5x squared and I have negative 3x, I cannot put these together because they're not alike, okay? So they will stay separate the way they are. I can't add them, I can't subtract them. If I want to add them, 5x squared plus negative 3x, and I'm saying, okay, add these two, you have to say that's all you can do to them, you know, you can't merge them, okay? They have to stay separate. Okay, so let's add and simplify in different questions. Add and then simplify, meaning if you have any like terms, if you can simplify those together by putting them together, you will do so. We have the first bracket for x minus 5. We don't have anything in front of it. That means we can just drop the bracket. We don't have to write it with. And if you have positive in front, another binomial, again, positive means just keep the same thing you have in the bracket. You're allowed to drop the bracket as well. So you have plus 3x and then plus 6 without the bracket. And now we have like terms. We have these terms that have x's in them, and we can put those together. So 4 plus 3 is 7, so 7x. And then we have the free terms. They're also alike. Negative 5 plus 6 is 1. So that's our final answer, polynomial. Yeah, so 4x and 3x are alike, right? So we put them together, we add them, right? So 4 plus 3 is 7, so 7x. So it's like apples. So you have 4 apples plus 3 apples. How many apples? 7 apples. You just do the same thing because it's negative 5, the numbers, right? So negative 5 plus 6, you just put them together. So you owe $5 with negative numbers. You can think about it as owing money. You put in that account $6. How much money you have in the account? $1, right? Because the $5 you paid off, and now you're starting to save $1, right? Make sense?
Can you say what was the possible?
So negative 5 plus 6.
Oh, I see. Yeah, okay.
Yeah.
Okay. Yeah.
Subtract and then simplify. So we have to subtract these two polynomials. So again, in front of the brackets, you have to really get rid of the brackets. Rules of order of operations apply. Brackets first, right? So you would have to do that one. You have nothing in front of it, meaning you can just keep everything as it is. Just copy it this time without the bracket, without the parentheses. And now when you have a negative in front of a bracket and you want to get rid of that bracket, negative means you have to switch all of the signs in the bracket. So here the first one is positive 3. Now it's going to be negative 3x squared. This one is positive 3x. It's going to be negative 3x. And this is negative 1. It's going to be plus 1. Okay, or in other words, apply the rule of signs. You can think about this negative as being negative 1, and then distribution, right? Like that. Multiply negative 1 by each of these coefficients. Negative 1 times positive 3 is negative 3. Negative 1 times positive 3 is negative 3. Negative 1 times negative 1 is positive 1. Okay, the rule of signs. Do you remember them? So positive times a negative is negative. Negative times a positive is negative. And if you have the same signs, they're always going to be positive. So different signs multiplied, you get a negative answer. Same signs multiplied or divided, you get positive answer. Clear? We'll remember that. So now, once we got rid of all these brackets, we're going to look for like terms to simplify our expression. The highest exponent is squared, so 2. We can put those together. So 7 apples minus 3 apples. How many apples? 4. 4x squared. And then for the x terms, we don't have any, right? We only have the x, the negative 3x. So we're just going to copy it, negative 3x. 3 terms or numbers we have, right? So we can put these together, negative 8 plus 1. What do you think the answer to that is? Not plus. Negative 7. So we owe $8. We put 1 towards it. We still owe 7, right? So that means negative 7. Okay. And that's our final answer for this subtraction. So if you have brackets, you get rid of them first, and then you just look to see how many like terms you have, and you put them together. That's called simplifying. Yeah. Yeah, bed mass, right? Like B would be bed mass. Okay, yeah. B, E. Yeah. It's a really good acronym, right? B stands for brackets, so you would do that first, brackets, and then if you have exponents, division, multiplication, addition, subtraction. In this case, in our example, we only used this, okay? And then we straight went to addition, subtraction. That's the only thing we had to do, right? But yes, brackets first.
Double brackets, use the brackets, between the brackets first.
Yeah. Yeah. If you have more than one bracket set, you always start from the inside most, the innermost bracket, and start canceling going towards the outside. Yeah. Yes. Good job, everyone. Let's go and do one more. For each of the given monomials, find a pair of like terms that added or subtracted will equal it. I will start, and then I'll ask you to create one pair as well. So negative 7x squared. I can add negative 3x squared and negative 4x squared, and I split it up, right? I still get the negative 7x squared. So how about you find a pair? Add them. So what other pair of like terms we can add that will give us negative 7x squared? Anyone? Plus negative 3x squared. If you do that, that's going to give you positive 7x squared. What should we, yeah, now we're going to leave the 10 because that's okay. You can start with anything you want. So you said 10x squared is the first one. Now, what do we have to add to 10x squared to get our negative 7? Nope. Negative 17, that's right. Make sense? Okay. Now let's do the part B. This was A. Let's do B with subtractions, okay? So 3x squared. I'm gonna choose 5x squared minus 2x squared. I choose the easy ones, and I'm letting you do the hard ones. But really, it doesn't really matter what they are, as long as we can split them up. So we want to subtract 2 terms. So my terms are these 2 that I subtracted. Yeah, 5x squared minus 3. Oh, it's not square. Yes, you're right. Keep losing my whiteout. Okay, so 5x minus 2x is my pair. Now for you, you choose. Luke, you want to try?
Okay.
12x minus 9x. Yeah, that works. So it can be an infinity of combinations.
No, that's not really.
Well, you just have to choose the coefficients, right? Because if we choose also an example for subtraction. So are we doing addition or subtraction? The question doesn't say, it says addition or subtraction. So we said we're going to do subtractions. Now, what two numbers subtracted give us 3? So 12 and 9. 12 minus 9 equals 3. You just have to put the x beside it to make it a term, right? So 12x minus 9x is 3x. And then here, another example. What two numbers subtracted will give us 3? Oh, I can choose 5 and 3. 5 and 2. 5 minus 2 equals 3. So it's just a creation exercise. It can be different kinds of answers. It can be actually an infinity of possibilities, okay? So these are just the 4 that we chose. Okay, so that was addition, subtraction, simplifying the like terms. We're moving into multiplying. Multiplying a monomial by a monomial. For this little exercise, you need to remember the product law for exponents. So that's way back to grade 9. So if you have 2 powers, same base, same or different exponents, we keep the base and we add the exponents. Okay, so for example, 3 squared times 3 to the 4, we say it's 3, we keep the base, and we say 2 plus 4, which is 6. That's the rule for multiplying powers. So now let's apply that to our polynomial multiplication. So we have here 11x squared times 2x. Now the coefficients are just multiplications of numbers. 11 times 2, you can just multiply, is 22, right? And now when we get to x squared times x, that's when this law applies, because x squared and x, now those are powers. Now what's the exponent of x? What's here? 1, we said, right? That means we keep the x, which is the base, and we add the exponents, 2 plus 1, which is 3. So the final answer of that multiplication is 22x squared, x cubed. Okay, next one. We're throwing in some signs now, and there's some negatives. Negative 3x squared times negative 4x cubed y. Well, because they're, yeah, you could definitely do that. In this situation, the brackets really don't have an important meaning, so I can just rewrite that as this: negative 3x squared times negative 4x cubed y. In between the variable, the x and the y, it's times. Remember that, okay? You don't have to write the dot for times, but it is there. Between negative 3 and x squared, also times. We just don't write the dot that represents multiplication. Okay, so now we take it by parts, and we start with signs and numbers. So negative times a negative, remember when you multiply same signs, you're gonna get a positive answer. And then you're gonna do the numbers, 3 times 4, which is 12, right? So we tackle the signs and the numbers, multiplications. And then we're gonna go to powers that have the same base, so we can apply this power law. So we have this x squared and x cubed that we're gonna multiply. We keep the x, we add the exponent, so 2 plus 3 is 5. And then y doesn't have anything to get multiplied by to use the power law, so you just attach it to it, so times y. That's our final answer. Positive, or 12 times x to the 5 times y. And the last one, some fractions. Negative 5, x cubed times 3 over 5. So I got rid of the bracket again to show you that it's not really necessary to have there the bracket. This one here more, normally you would see it like that because in math we say never put two operation signs side by side. So you will never have a positive and a negative without a bracket surrounding it, okay? So that we always separate them when they're different and side by side, okay? So that's why this bracket is more needed than this one over here. Sounds good? So now let's tackle the multiplication. So we have negative times a positive. We know our final answer will be a negative coefficient answer, negative from here, positive from there. And then we have, I'm going to write it beside it so you can see the cancellation. 5 times 3/5. Now 5 is a whole number. I can write it as a fraction by putting it over 1. 5 over 1. Okay? And then we say we can cancel these numbers because I have a 5 at the top here in the numerator and I have a 5 at the bottom here in the denominator. So I can divide top and bottom by 5 and I'm going to get ones here. 5 divided by 5 is 1. 5 divided by 5 is 1 there as well. So that's called canceling, simplifying. And then the 3, I can't do anything with it, but I will simplify in my next step. And now x cubed times x. I can apply the power law again. We have x as the base, and then we have 3 and 1 in the exponent. 3 plus 1 is 4. Now let's simplify even more. Negative 1 times 3 is 3, divided by 1 times 1, which is 1. So negative 3 x to the 4. Final answer. Final. Remember these ones? For some of you might be just too easy, right? No?
I remember a little bit back.
A little bit, yeah. So a side note that for those of you that this is a little bit too easy, you got to remember that in adult ed, we have a variety of abilities. Students that come to adult ed may have all of the prerequisites, so may have grade 9, 10, 11 pre-calculus, and they just finished it and just probably didn't take grade 12 in high school. But we also can have students that didn't have, or they have grade 9 20 years ago or 10 years ago, you know, or they skipped all of the pre-calculus classes. They only, exactly, yeah. So we, not so much, but yes, they're all math, you know, but the essential would be dealing with everyday math, you know, making sure you know your personal finances, how to deal with them. This is preparation for calculus, right? So it's a different goal type of math. Algebra. Yeah, so we have all these different kinds of abilities here. Try not to get motivation from looking left and right, because it's not going to be good for you. Because you might see students, oh, they're already leaving. They might be leaving for different reasons. Either they know all too well, or they got overwhelmed. It's too much for them. Wrong class, you know, similar things like that. So, yeah, make sure you focus on your own progress. And be patient with people that need extra explanations. Okay, so multiplying now monomial times a binomial or polynomial, it doesn't really matter. The method will be the same. It's called distribution. So when we multiply a monomial by a polynomial, that monomial has to be multiplied with each of the terms in the second polynomial. So here we have in this example 5. So 5 is the monomial. It has to be multiplied by 2x, and it also has to be multiplied by positive 1. In that process, the bracket disappears. Okay, so when you distribute over that multiplication, you're not going to have a bracket anymore.
Example B was confusing a bit. Is like I was kind of thinking of the distribution on that one. So when you multiply the power of 2 times the power of 3.
Are you in part B?
I'm going back one to example 4.
Yeah.
Question either, but I would say negative 3x squared.
Yeah.
Bracket negative 4x cubed.
Yeah.
So we don't distribute there, right? It's only if it's like more than one term.
That's right, yeah. So this was monomial times a monomial. Now we're going monomial times binomial or polynomial, more than two terms. And in that sense, then that's when you have to do distribution, right? You'll see plus, subtraction, and all that, yeah. So 5 times 2x. Now, these individual arrows would represent these questions right here, right? Because it's going to be for each of these multiplication, an example of a monomial times a monomial, right? So 5 times 2x, 5 times 2 is 10, x comes along. And then 5 times positive 1 is just positive 5, that comes along. Done. Yeah, okay, good. Yeah, that's okay. All good. First class, right, too. Now, we have negative 3 over 14 the times 2x minus 7 in brackets. So we're going to have to multiply that number by that. So by 2x and by negative 7. The first multiplication, I'm going to break it apart again because it's a fraction so you can see the cancellation. So that's the first arrow. And then the second one, we have negative times a negative is a positive. 3 over 14 times 7. Now we're going to deal with the cancellations. So here we have 14 and 2. What can we divide them by? What's the common divisor of both of those numbers? Not 7, because I can't divide 2 by 7, 2, right? So 2 divided by 2 is 1. 14 divided by 2 is 7. Okay, so that's the cancellation. And now on the other side, on the other multiplication, we have 7 over 1 there. What can we divide 7 and 14 by? This time is 7, because 7 divided by 7 is 1. 14 divided by 7 is 2. So when you're canceling, you also have to cancel by the same number, both top and bottom.
Can I go this way?
Yeah, you can do that. It's always diagonally or vertically, okay, not side by side, okay? Now we're putting them all together. Negative 3 times 1 is negative 3, and 7 times 1 is 7. So your answer will be negative 3 over 7. X comes along. We didn't have to do any power law for our x's. And then 3 times 1 at the top is 3, and then 2 times 1 at the bottom is 2. So plus 3 over 2. And for part B. Binomial times a binomial. This is also distribution, but you have to do it twice. There's a nice little memorizing tool for it, for binomial times a binomial. It's called FOIL. It tells you the order in which to do those multiplications, those distributions. So the first term here with the first term there, that's the F in the FOIL method. And then the first and the outer terms right there, that's the O. First outer. And then the inner terms, that's the I. And L stands for the last terms in each bracket. I always found this one quite not very needed, because once you get that each term has to multiply so if you start with the 2x, you have to multiply by both of the ones in the second bracket. Then you go into the next one, negative 3, you have to multiply by both terms in the second bracket. So yeah, so if you need it, use it. But once you understand what distribution means, it's pretty easily applicable to all kinds of situations. So let's do that. Follow through. 2x times negative 4x. So this one, monomial times a monomial. We get a negative because I have positive times a negative, and then 2 times 4 is 8. X times x is x squared. So x to the 1 plus 1, right? X squared. Then the second multiplication, 2x times positive 1. 2x times 1 is just 2x, positive 2x. And then we have the inner terms, negative 3 times negative 4x. Negative times a negative is positive. 3 times 4 is 12. And then x comes along. And then the last one, negative 3 times positive 1 is negative 3. Now, you sometimes end up with some like terms. When you do, you're not done yet. You have to simplify. You have to put them together. So what are our like terms in this expression? 2x and 12x. We can put them together and rewrite it as 14x. That's right. So negative 8x squared, we just copy. These two, we blend them together. We write 14x. And negative 3, we just copy. That's our answer to this multiplication. I added these two terms, the 2 and the 12x. All good? Sorry? There is, yeah. Can you feel it? Okay, and I have another method to show you. If you like this method, especially when you have to multiply bigger or multiple terms polynomials, like 3 or more, the grid method helps. It's also very helpful for mental math applications when you have to multiply, for example, 35 times 75. You can split the numbers into units, tens, hundreds, and apply the same method, okay, for multiplication. So for us, it works like a grid. So you make up sort of a tic-tac-toe grid. At the top line, we put our first polynomial. It doesn't really matter which one. Splitting up the terms like that separately, 2x minus 3. And then on the left-hand side column, we're going to put our second polynomial vertically, term by term. So negative 4x and 1 or positive 1. And there's our grid. So we're doing exactly the same multiplication, the same question, okay? We're going to get the same answer, but we approach it differently, okay? So in each of these inside squares, we're going to get our answers to the individual multiplications that can happen between each of these terms. So where they meet, you have the answer. 2x times negative 4x, we get negative 8x squared. So these two multiplication, the answer is there. Make sense? These two, the answer is going to be there. Negative 3 times negative 4x, we get positive 12x. These two multiplied, we can put it over there. 2x times 1 is positive 2x. Negative 3 times positive 1 is negative 3. Do we have any like terms? Yeah, we do. Those are like terms. You're going to put them together. Now, final answer. Negative 8x squared, so the highest exponent polynomial. Or term, better said. These two terms, we can merge them together. 12x plus 2x is positive 14x. And then this term is by itself, minus 3. So same answer, different. Exactly. Yeah. Exactly. So whichever it works, yeah. But I like this one again for mental math, right? So you do 75 times 31. You can just do 70 and then 5. And you do 30 and 1. And then you just multiply through 3 times 7 is 21, 3100. and then 150 and 70 and 5, and then you just add all these together, right? It's pretty cool. You don't need a calculator to do it, right? If you understand this method. So, dividing. I'm only going to do a little bit of intro on dividing monomials, and then we're going to have a short break, okay? And then we're going to get into our actual notes. So that's probably going to be around 4. So dividing monomials, for these, you're going to need to remember the quotient law of dividing powers. So same base, different exponents, or same exponents, we keep the base and we subtract the exponents in the order they appear. So example, if I have 3 to the 11 divided by 3 to the 4, the answer will be 3. So we keep the base and we do 11 minus 4 in that order. So that will be 7, right? 11 minus 4 equals 7. So let's apply that to polynomials, monomial kind. 16x squared divided by 2x. The numbers coefficients, we just divide them. 16 divided by 2 is 8. X squared divided by x. X we keep, 2 minus 1. So the answer is 8x to the 1, or just 8x. We don't write the 1 in the exponents. Still division, but written as a fraction. Remember, the division line means, or can be written as a fraction line, the same thing. And we still have to divide -3 divided by -6. Negative divided by a negative, rule of signs, your answer will be positive. 3 and 6. Can we cancel it out? Yeah. That's right. So we can divide both 3 and 6 by 3. So we get 1 and 2. You can actually get an answer to that division. You can say 0.5 if you want for that fraction. As long as it's an exact decimal, you can use decimals or fractions. If you have 1/3, then don't write 0.3, okay? Because that's not exactly equal to 1/3. But you can write 0.3 with the repeating line at the top, that's equal to, okay? So if you can find a decimal that equals to your fractions, you can use both. If you cannot, if you have to round, then keep the fractions. So keep the exact number instead. So we have positive, and then we have 1/2. And then we have to deal with the power. So x to the 5 divided by x cubed. We have x in the base, 5 minus 3, which is 2. Okay, so 1/2 x squared. Okay, so now -5x cubed divided by 3/5x cubed. Now here I'm using this example to reintroduce you to division, the fractions, okay? So what our job is with these coefficients is to divide them. So we have -5 divided by 3/5. And the way we do it is we keep the first fraction, the -5/1, the same. So -5/1. And then we convert the division into times, and then we do the reciprocal of the number that we divide by. So 5/3. So we have to change the sign and then divide. We change it into multiplication and then reciprocal. So now you multiply top, top, bottom, bottom. You can cancel some things if you can, but no. Reciprocal, you just flip them over, right? So 5 goes into, it's actually 1/3/5. That's how we write the reciprocal of a number, okay? But when you do that, that's what happens. It just flips over the numerator with the denominator. They change positions. Okay, so now multiply through. -5 times 5 is -25, and then 1 times 3 is 3. So we will end up with -25/3. And then we still have to deal with our x's, right? So we have x, keep the base, and then what do we do with the exponents? We subtract them. X to the 0, which is 1. As long as x is not 0. So usually we don't have this rule for 0 to the 0. So it has to be something different than 0, right? But anything to the exponent of 0 equals 1 by definition for powers. Yep.
Not this sort of question, but it doesn't matter where that negative sign, whether it's right next to the line.
Yeah, it's a very good question. So does it matter where we write the negative sign? It doesn't really matter. So negative 25 over 3 means the number 25 over 3 is a negative number. But I can also write a similar idea by saying negative 25 divided by 3. You're still going to get the same answer. You can also write positive 25 over negative 3. Still going to get the same answer, because you're always going to have to apply the rule of signs, okay? So yes, very good question.
So on the initial answer, negative 25 minus 3, we left the blank space, right? That's just to show us that the x is missing now because x is 0.
Right here, or
A little bit low.
this here,
Right.
this,
Right.
but yeah, here, because he times it by 1, there's no more x, you know? These are just steps, right? So here I apply the rule to show you that the rule still applies. 3 minus 3, you end up with a 0. Then what do? Do you leave it as x to the 0? No, you don't. Okay, you say it's actually nothing there because something to the 0 is 1. Okay, again, with the exception of 0. That's our answer. Break time, 5 minutes. So 4:05. I like to do that. And at the breaks, I write the time when we should be back. So then if you're out of the building or you're going to get snacks, then you know when notes start again, okay? During this time, you can do extra practice questions, go and stretch your legs, up to you, you know. Remember, you have these keys at the back of the booklet. Yeah, it does. It gets trickier, but it's doable. Like it's not, yeah. Yeah.
Internet has lots of stuff on it too, right?
Definitely.
I'm good looking at kind of stuff for learning for watching videos.
Yeah. Actually, for pre-calc, there's so much more resources than for applied or essential. Because pre-calc it's a type of algebra, you can say, and there's a lot of US videos and resources out there that match with our pre-calculus course.
Yeah.
But applied is two different, altogether different course. So. Where are we? Long division. I lost track of these.
Your turn 1.2.
That's your turn. That's you do those questions by yourself. The keys, the answer keys are at the back of this booklet. Sounds good? You should be doing them all, okay? Unless you think it's too easy for me. But I always say you should do some easy questions to get some confidence, you know, like, well, I know something, you know, and then you do them just so you can get that, okay, feeling that you learn something and then you're moving towards more like harder things. When I used to ask my math teacher, because we didn't get all questions, like I give you handouts and all of it is worksheets, all of those are practice questions. Back in the days when I went to high school, we had textbooks, you know, so then every day you would have a set of questions from the textbook with, hey, example 1, ABC, you know, and then it would ask, sorry, so like, which one again, you know, how many questions? All questions. He will never repeat it again, you know, how many, but all questions.
Yeah, I think like my high school, we had textbooks, not just math, but like any textbook, and they had examples in it.
Yeah.
And then they would just be like, oh, just
before we get to how to do the long division of polynomials, we need to learn some terms. Dividend is what is being divided. For us, the polynomial that we will be dividing. The divisor is what we divide by, what is used to divide. Quotient is the answer, the main answer to this division. The division. And remainder is what is left when a division is not, let's call it perfect, okay, not complete. Okay. The leftover of an incomplete or not perfect division. So here's an example with numbers. Okay, just like I've done it for powers with 3 to the power of, I'm going to use just numbers, not polynomials. So let's say 7 divided by 3. Okay. Now, what's the whole number answer to that division? You can fit 3 into 7 2 times, right? And then we have plus a remainder of 1, okay, like that. So then 7 would be the dividend, 3 would be the divisor, 2 is the quotient, and 1 would be the remainder. We can also write this division as 7 divided by 3 equals 2 plus 1 over 3. And this is actually a better equality for us because it's mathematically correct. Okay, so if I add 2 and 1/3, I'm going to get 7 over 3. Make sense? If you take a math class in university called number theory, you'll do these forms quite a bit. Okay, now before we can actually learn how to divide the polynomials, we also have to do these 2 things. We have to make sure our given polynomials are always going to be in general form. That means from the highest exponent to the lowest exponent, because sometimes they're given to you scrambled because you're learning about these algorithms, and you have to do that step first. So write polynomials in descending or decreasing order of exponents. So this one, remember, it's called general form. If the question wants to be tricky, it would not tell you anything about it, right? So just to divide, and they're all not in the proper order. Now, some polynomials may miss the terms. They're not always there. So for example, we can be given a polynomial that looks like 5x squared minus 3. If I start writing it in the order of exponents decreasing from 3, I'm missing 2 and I'm missing 1, right? That makes sense? I'm missing 1, not 2, 2 is there. So 2, 1, the 1 is missing. So for all of the pieces that are not, they're missing, you have to put a place for them. And the way we can do the place is write the exponent we are missing, but put a 0 in front of it because 0 times x is still 0. So you're not really putting anything in there. You're just putting the place for it. Clear? Sort of? Okay. So write missing terms as 0 times x to whatever n you're missing. If you don't, when we have the algorithm work, the terms that are alike, they're not going to line up. You're going to be with an x squared underneath an x cubed, right? So when you put those places, they're going to be nicely written in the algorithm. Okay. Have you done long division in grade 7? Yeah, so that's what this is, but for polynomial. So it's a step-by-step procedure. That's what the word algorithm means, step-by-step procedure. So if you follow that procedure, you always will get the right answer, okay? So step-by-step, never going away from it. So for each division below, divide using long division. We're going to state the quotient and the remainder to them. So this is our dividend, this is our divisor. First, we want to make sure that they are in the order that they should be in. And then if we're having any missing terms, we're going to write it as 0 times that missing power. So for the dividend, we're going to start with that. Give yourself a little bit of room here. Okay, so do this kind of line like this, like a sideways L. And underneath it, we're going to do those 2 steps all in one go. So we have the first term should be 3x cubed. Do I have a terms with x squared, which should follow it? No, so I have to write it for descending order of exponents. So we don't. Then we write a place for it, plus 0x squared. So this term was not there. Okay, I'm just putting a place for it. 0 times x squared is still 0. I haven't added anything in. Okay, just a place. You can put negative 0x squared. It doesn't really matter, right? As long as you have 0 there. Okay, now do we have a term with x in the given polynomial? Yes, there it is, right? So we just copy that one, negative 7x. So we have 3, 2, 1, and then nothing, or the free term, which is plus 5. So that's our first step, making sure our polynomial that we are dividing, the dividend, is in order from the highest to the lowest. Okay, and then if you have any missing terms, like we had the square term missing, we put 0 times it. Okay, now on the left-hand side of this sideways L, we write the polynomial we divide by, which in this case is x plus 2. Okay, we have A, B, C of this question. Be patient with yourself because the algorithm is not going to click right from the beginning, okay? Yes, okay, so the first one, maybe you'll get 1 step, in the second one you'll get, oh, now I get the second step of it too, and the third one, hopefully, you can put it all together and it makes sense. What are they? Okay, now I would call this side division, so this is side calculation. These side calculations happen in my mind, okay? I don't do these on paper when I do long division, and that's the goal for you too. You don't have to need the side calculation, but for now, because we're still learning the algorithm, you can write them on the side to keep track of what you're doing, okay? The first thing we do is take the first term of the dividend and we divide it by the first term of a divisor. So we have to do on the side calculation, 3x cubed divided by x. And we get 3 divided by 1, which is 3, x cubed divided by x, which is x squared. And this is going to be the first term of our quotient, our answer. So we write it here at the top, 3x squared. So the first division, we do it. We get our first 3. This is a 3 here. X cubed. It's from here. 3x cubed. We take, yeah, and we divide them. Everybody got the first step there? Okay, and that's again the first term of our answer. Now we have to have a way to continue this and keep reducing this polynomial until we cannot reduce it any further. And the way we do that, okay, we're gonna multiply the 3x squared with each of the term of the divisor. So we do this distribution. That's our third step of the algorithm. So 3x squared times x, we have to get exactly the same term we started with, which is 3x cubed. And then we do 3x squared times 2x, which we're gonna get 6x squared. See how the term that was missing now is lining up with another x squared term? If you don't put that there, you're now gonna be under 7x, and you cannot put those together because they're not alike. Okay, so it's very important to have a place for it. Okay, and now once you have that, what we do is subtract vertically. subtract a binomial. Okay, so careful with that. And then you do 3x cubed minus 3x cubed. What you're gonna get here in the first subtraction? Zero, nothing. I like to put a line so I don't have extra numbers, so nothing. And that should always be the case. If you don't get nothing there, something went wrong, okay? You should always get nothing in that first subtraction. Now the next one, you should get a number for your coefficient. So 0x squared minus 6x squared. What you're getting here? Negative 6x squared. And this completes the first big step of the algorithm. And now from now on, the algorithm repeats, right? So revise. You take the first from here and the first from there, you divide them, side calculation. You get 3x squared, you put it at the top. Multiply through, put the answers there, subtract vertically. First one has to cancel, and then the second one, you have to calculate what you get when you put those like terms together. Now we're gonna continue the same thing, okay? Now we need a second term here, so we're gonna drop it from what's left of our polynomial. What's left is negative 7x plus 5. You can drop the entire thing or just send the next one. You don't need the entire thing. So negative 7x dropped. Repeat. So the first one from here, and the first one always going to be from there because you don't have anything else. So side calculation number 2, negative 6x squared divided by x. What are we getting? Negative 6x. Where does this go? Right here at the top, okay? It's important to put positive, negative, because it will help you to connect the terms, okay? Because if you have positive, for example, here, what you're gonna do, just attach it, you can. Because it's still plus minus in between the terms in your final answer. So here, the negative 6x becomes subtract 6x. What's the next step? Arrows, right? Multiplication. 6x, negative 6x times x is negative 6x squared. Negative 6x times positive 2 equals negative 12x. And then we subtract vertically. Negative 6x squared, subtract negative 6x squared. What are we getting? Take away the same thing? Nothing. Negative 7x, attention here, subtract negative 12x is the same thing as saying negative 7x plus 12x. So the answer is positive . How many x's? 7 plus 12. Negative 7 plus 12. 5. Okay. Confidently 5. Sorry? 19? No, it's not 19. If this would be positive, if we add vertically, then yeah, it'll be 19 because you're getting a bigger, but we're subtracting 2 negatives. So the second negative, negative times the negative, it's positive. So you're basically adding 12x there. Okay, that needs to simmer down a little bit, okay, to make sure. Yeah. I have a little trick for this one to kind of avoid the rule of sign. I'll show you my trick, but I want you to learn first the algorithm the fancy way. Okay, it's subtract vertically, okay, but then I'll show you the trick. Sounds good? Okay. So 5x, let's drop the plus 5 and let's repeat the algorithm. 5x, can we still divide by x? Yes, right? So 5x divided by x, we get, yeah, and I like to put plus 5, positive 5. So then when you put it in the answer, you know it's plus 5. You don't just put 5 there. You don't want to put negative 6x5 there, right? So negative 6 plus 5. And then multiply 5 times x is 5x. 5 times 2 is 10, positive 10. Subtract vertically. Nothing for the first subtraction. 5x minus 10 is negative 5. That's our remainder. And here at the top of our line, that's what we call the quotient, the answer to this division. The question states that we need to say which one is the quotient and which one is the remainder. Okay, this one was slow. We're gonna press the gas pedal a little bit for the second one, okay? But we're gonna keep repeating the same algorithm until the part C. Okay, so 6x squared plus 2x minus 4x cubed plus 1. They're all scrambled, so let's unscramble them. Negative 4x cubed plus 6x squared plus 2x plus 1 divided by 2x minus 1. Side calculation, negative 4x cubed divided by 2x, we get negative 2x squared. Everybody clear with that? This divided by that. This answer is the first term of our quotient. So negative 2x squared, you write it there at the top. Multiply through to continue. Negative 2x squared times 2x, we get negative 4x cubed. And negative 2x squared times negative 1, we get positive 2x squared. Now what we want is to subtract this binomial vertically. When you put a subtract sign in front of a binomial, what happens to the signs of that binomial? They change, right? So that's my trick. Instead of putting subtract bracket, just change the signs and use those signs for your merging of the like terms, right? So now you have negative 4 and plus 4. What does that make? Nothing, 0. You have 6 from here, but you have negative 2 from there. What does that mean together? 4x squared. Make sense? It's still subtract vertically, but a little bit faster. Let's drop plus 2x and repeat. 4x squared from here divided by 2x from here equals 2x. Where does this one go? Positive 2x plus 2x there. So far, so good? Okay. Multiply. 2x times 2x is 4x squared. 2x times negative 1 is subtract 2x. Putting subtract a binomial, what does that do? Changes the signs, right? So here we have negative, here we have positive. Like terms together, nothing. Like terms together, 2 plus 2 is 4x. And last one is drop the 1. And last algorithm. 4x divided by 2x. Side calculation, these can happen in your mind if you can reach that level. We have 2, x divided by x is 1, so nothing, no variable anymore, so plus 2. Multiplication, 2 times 2x is 4x, 2 times -1, -2. Oops, I wanted to keep it same color. And now we change the signs for subtract vertically. Nothing here, 1 plus 2 is 3. That's our remainder. Where's our quotient, our answer? Right here, that's our quotient. So when you divide a cubic by a linear, what you're gonna get? A quadratic, right? Degree 2. If you divide degree 5 by degree 2, you get a cubic, you know, so it's always that first division that tells you the type of polynomial your answer will be. Another one. So let's get our setup. Make sure your dividend is in order. Any missing terms, put 0. So we have x squared, so negative x squared. Do we have x to the 1? Yes, we do. Plus 4x to the 1 and plus 23. Divided by x minus 3. Negative x squared divided by x. Negative x. Multiply through. We get negative x squared positive 3x. Change the signs because it's subtract vertically. The x squared terms is gone. 4x minus 3x, 1x. Or just x, yes. And then x divided by x is 1 plus 1 in the quotient. Both of these, they go in the quotient. And then multiply through. 1 times x is x, or 1x. 1 times -3, -3. Change the signs. Negative, positive. Nothing in the first subtraction. 23 plus 3 is 26. That's our remainder. So sometimes, not sometimes, most of the times I write R. I don't write remainder. And then top here, I don't write quotient, I write Q, so shorter. You can do so as well, as long as you know it. Yeah, I use Q instead of quotient, the entire word. Same for remainder, I use R instead of the word remainder. How are you feeling? Okay. Yeah, yeah, hopefully, yeah. So
When the signs start changing on you.
yeah. So then, like I said here on page 11, the algorithm itself is after you multiply through, you get the binomial, you're subtracting this binomial from the first 2 terms, okay? And because you have a negative in front of a binomial, the signs will change when you do so, okay? Now this was easy because they're both positive. Okay, so that works really well here. But when we get to situations like this, when we had to scratch our brains, so what was that? Was it -17? We weren't sure, right? When you change the signs first, that helps quite a bit, okay? And you just put the like terms together vertically then, okay? But the changing of the signs comes from this subtract vertically, okay? You're subtracting a binomial. Make sense? Okay. So you have a couple of questions here to try. The keys for these step-by-step keys solutions are at the back of this booklet. Let's tackle synthetic division. Synthetic division of polynomials basically takes this algorithm of long division and simplifies it, right? Synthesizes it, and it's more fun to do for sure. Before we can use the algorithm, we have to write our polynomials again in descending order of the exponents, and you have to write or imagine your missing terms as 0 times x to the n. So exactly the same procedure. Before you start the division, make sure these 2 steps are done. I would definitely write this down in my summary sheet, okay? So, hey, before I start, make sure I do the setup correctly, because if you start with the wrong setup, then the whole thing is gone, okay? So now that you've done that, well, let's do that for the first one. We're only going to use for the algorithm the coefficients of each of these polynomials. And from the divisor, we only divide by the binomial x minus a. We're always going to take the opposite sign for that subtraction. So if I have binomial x minus 1, I'm going to use +1. If I have binomial x plus 4, I'm going to use -4. So always opposite of the number you see. So let's first write it in the descending order. And I'm going to write it for the first example, but then you can simplify it quite faster without rewriting it. So we have x to the 4 for this one. We don't have cubed terms, so +0 x cubed. And then we have +8x squared +12x and -5. And because the synthetic division is always going to be by this binomial form, x minus a, okay? This a from here is this opposite number I'm talking about. So what is a from x minus 1? A is 1 all the time. So opposite sign you see in the binomial. Now the setup of the synthetic division, it's still going to be sort of like an L, but looking like this. Imagine this L fitting 2 rows. Each of these coefficients, they will go in the top row. So I'm going to write, so imagine leaving the bottom row empty and then fill in the top row with these coefficients. So we don't write the x's anymore. We're simplifying the division, synthetic division. You write 1, 0, 8, 12, -5. And the a value will go right there in the corner. So we write 1 right there. This a from the x minus 1 goes right there. And we drop this first coefficient underneath the line to be able to start the algorithm. Okay, so one more time. Make sure it's in descending order with missing terms written as 0x to whatever it's missing. Then set up the L and write only the coefficients in the first row. And then use the divisor, but only the a value of it, and put it on the left-hand side of this L. Drop the first number in the list, and now we can start the algorithm. Okay, all of this was just set up. Okay, now how does it work? You multiply these 2 numbers first, so 1 times 1, and you put the answer underneath the next number. So 1 times 1 is 1, okay? And then we add vertically. So what is 0 plus 1? 1, right? And we write the answer underneath the line now. We keep doing the same thing. Now we take the 1 from here, and the next number that we just wrote, the 1 from here. So 1 times this one from there is 1. And we add the next pair vertically. 8 plus 1 is 9. And then we do it again. 1 times 9 is 9. We write it underneath the next number. 9 plus 12 is 21. And 1 times 21 is 21. And then 21 minus 5 or negative 5 plus 21 is and that last number you write, that's the remainder. Now, where's the quotient? Because all you got numbers here. Where do you think the quotient will be? Right here. But you only get in synthetic division the coefficients of your terms. So you have to fill in your final answer now with the x's as well, okay? The same thing like we started here, we started with the terms that have x's, but we took them off to apply the algorithm. Now that the algorithm is done and I know what the remainder is, and I know what the quotient is, I have to put my x's back in. The easiest way to put your x's back in is to start at the end, at the right-hand side. Because this first term here is the free term, okay? It's the back of that tail. So nothing, no x here. This is a positive 21, so I'll add here. And then the next term, the 9, will have x. So you go up in exponents. So x, positive, because 9 was positive 9, and then x squared. And then positive x cubed. So what's my quotient? X cubed plus x squared plus 9x plus 21. And the remainder is 16. One more. Let's write it in order. X to the 4 plus 0x cubed plus 2x squared minus 5x minus 1. So we have a 1 here. If we don't see it, make sure you write it. It's not 0 in front of x squared, x to the 4. It's 1. Those are our coefficients. So let's set it up. 1, 0, 2, negative 5, negative 1. Now on the left-hand side is our a value. What's our a value from x plus 4? Negative 4. Negative 4 goes there. We're not done the setup. We have to have something to multiply negative 4 by. So we have to drop this first number underneath the line. There it is. Now we can start. Negative 4 times 1. The answer is negative 4. Add vertically. So negative 4. Negative 4 times negative 4 is positive 16. Positive 16. And then we're going to add vertically. We get 18. Negative 4 times 18. Negative times a positive. This one is a negative answer. 4 times 10 is 40. 4 times 8 is 32. So 40 plus 32 is 72. Add vertically. Negative 77. Negative 4 times negative 77. Negative 4 times negative is a positive. 4 times 70, that's 280. And 4 times 7, 28. Right? So 280 plus 28 is 308, right? 308 plus negative 1. So we add them vertically is 307. That's our remainder. That last number, the remainder. The quotient is going to be here, but it's not complete yet. So what do? Nothing for the free term. X plus x squared. I don't have to do anything to negative 4 because it's already there connecting it to the next term. So stays at subtract and then x cubed. our quotient is x cubed minus 4x squared plus 18x minus 77. And the remainder is 307. By next class. Yeah. So you're gonna drill synthetic and long division of this weekend. Okay, you're gonna have a quiz on these two, only 2 questions, I think, if I remember correctly. So 1 long division and 1 synthetic division, right? So your turn 1.4, make sure you do these practice. Again, you have solutions, right? Exactly step by step. So if you mess up at the 1 step, you can compare and say, hey, this is where I didn't get the same answer. The homework only has answers.
Oh, I see.
So sort of you're building up stamina to work towards that. Now, what I want to finalize our class with is when we finish either long division or synthetic division, how can we write our answer in a statement, that completes the division? The same way that I wrote for you that 7 divided by 3 equals 2 plus 1/3. Okay, that's one we call division statement, an equality that's true, okay, where I can see the divisor, the dividend, I can see the quotient, I can see the remainder, and also the divisor there. And I also can write the same statement as the 7 equals 2 times 3 plus 1, okay? And that's also going to give me an equality that's true mathematically. And it's another type of statement that we can write our final answers in. So this fancy notation that you have right here, P of x divided by Q by D of x equals Q of x plus R of x over D of x. It's just a fancy notation for that form, right? There, the 7 over 3 equals 2 plus 1/3. Make sense? And then this fancy notation here is corresponding to that statement. That 7, number 7 can be written as 2 times 3 plus 1. The letter P stands for polynomial that's being divided, or the dividend of this division. The letter D is the divisor, or D of x is the divisor. Q is quotient. R of x, or R, is going to be the remainder. Okay. I get this question a lot. Which way do you want me to report the final answer when the question says write a division statement? It doesn't say in both ways. Sometimes it just says write your answer as a division statement. When it's not specified, you choose, okay, either 1 or 2, okay? When it's specified, it will tell you which one, okay? And then you have to show it in that way. The simplified answer to that question would be you have to know both. So it's either or, know them both, learn them both. So let's start with example 10, where a question is already done for us, a synthetic division. So our answer is right there. Here's our remainder. 3 term, x squared, x term, and then the x squared term. So the quotient is 2x squared minus 6x plus 16. That's the Q, right? Now, where is the polynomial that's being divided? Remember how we started the algorithm? That's going to be the polynomial that's being divided. But also doesn't have the x's because this question is already done. So you do the same thing we do for the quotient. We just put in the x's from the right-hand side all the way to the left-hand side. So no x there, an x there, and then x squared, and then x cubed. And then on the left here is the simplified version of the binomial x minus a. But remember, we read it oppositely. So now when we put it back in the form x minus a, we're going to, again, use the sign in an opposite fashion. So what's the divisor? It's going to be x, not minus 1, plus 1. or in other words, x minus minus 1, that becomes x plus 1. Yeah. Now division statement, I'm going to keep it in the same numbering. So the number 1 is going to correspond to the notes here. Number 1, it's just an aleatory choice. It doesn't really have to be always called number 1 statement. The first type, we're going to write it like this: 2x cubed minus 4x squared plus 10x plus 11. And it has to be divided by the divisor, the d of x plus 1. Equals, and then we write the quotient, the 2x squared minus 6x plus 16, and then we add a fraction where we put the remainder at the top, -5, and the x plus 1 again at the bottom, the divisor, like that. So the location of all of these correspond to the location of the formula, okay? Just you can think of this one as being a formula, okay? If you add these two, you'll get that, okay? How do you add two fractions? You would have to bring them to the same denominator, right? And do the like terms. You do the cancellation, you end up with the same thing that you have here on the left-hand side. So this equality is true if the division that you've done is correct. Make sense? Okay, now how do I write it the other way with p of x only on the left-hand side? So we start with 2x cubed minus 4x squared plus 10x plus 11 equals d of x first. So x plus 1, I'm going to put it in bracket. And then times it by the quotient. So inside the bracket, the quotient, 2x squared minus 6x plus 16. And then add the remainder. This is also a true equality. How do you get rid of these brackets? You have to multiply the polynomials. And then you're going to end up with some like terms, okay, even a free term. And the free terms have to be merged together. When you finish with all the cancellation and all the simplifying, you'll end up with this polynomial, the p of x. So this is p of x, that's d of x, that's q of x, that's r of x. Okay? So dividend, divisor, quotient, and remainder. Ten minutes left. Usually we don't go as long, but today, because of the intro, it runs a little bit longer than I am teaching usually. Usually at the end, we're going to have our little quizzes. So when a polynomial p of x is divided by x minus 5, the quotient is 2x squared plus x minus 1, and the remainder is -3. State p of x in general form, meaning from the highest exponent to the lowest exponent, okay? Now, you have to state p of x, but you don't know what p of x is. So because you're doing long division, synthetic division, division algorithms, and writing synthetic and long division statements, obviously when you see a question like that, you should think about these things you learned in lesson 1. Now, do I have a statement that describes what p of x is when I know quotient, divisor, and remainder? And the answer is yes. You have that second statement that tells you exactly what p of x is by using all of these parts of the division. So p of x, it stays, is d of x times q of x plus r of x, right? That's the statement you have. Do I know what the d of x is? When a polynomial p of x is divided by, that's our d of x, right? What you're dividing by. So I replace d of x with x minus 5. The quotient is, do I know what the quotient is? Yes, because it's telling me right there. the quotient is 2x squared plus x minus 1. So I'm replacing it into the statement. And the remainder is -3 plus -3. So I add the remainder. Now, am I done? Partly, like I'm on the right track. I don't know exactly what P of X is in general form. I would have to actually complete this multiplication and addition. Do I know how to multiply polynomials? Yes, we reviewed that together. Okay, so let's do so. This is a binomial and this is a trinomial. You can do distribution a little bit longer than FOIL, or you can do the tic-tac-toe grid method. It's really up to you which one you're gonna do. So the grid method is gonna be like this: x and minus 5, and then 2x squared, x -1, like that. So we're gonna have our 2x cubed, -10x squared, x squared, -5x, -1x, and +5. Like terms, like terms. Diagonally? Well, it just happens that they match diagonally, but they don't always match in the same way. So you look for the terms that have the same power. So x squared power, they're the same, the x power are the same, okay? So now the cubic one doesn't have a partner, so we just copy it. 2x cubed. -10 plus 1 is -9x squared. The -5 and the -1 together makes it -6x. Now attention to the +5 here, because this one also has a partner that we left out, right? We only tackled using this grid method, the multiplication here, right? But the statement also has the remainder there by itself that we have to add to whatever we get in our multiplication. So late at the last step, you have to do 5 plus -3, which is 5 minus 3, which is 2, so +2. That's P of X, folks. And that's it for today, I think. Yep. So as a plan for you for the weekend, do all your turn exercises in the notes. So every single one of these pages that we left out, okay? Make sure you complete them so you can practice. When you're confident that you know what you're doing, then move on to worksheet number 1 in your homework booklet. You only have divisions there. You have one question with long divisions, one question with synthetic division, okay? And if you have everything done, you will be ready for your first assessment. So next class, at the end of the lesson, you will do the assessment, okay?
What is what?
Your turns, or these ones, the your turn exercises pages.
The W.
Worksheet, yeah. I was able to record myself, so I will find a way to post the recording on Google Classroom. So if you need to revise the algorithms, you can find the recording on Google Classroom. I'll label it so you recognize it, okay? Day 1, for example, okay?
I thought that there was some already on there.
There are old ones, but I don't think they're available.